Hi guys, we're on lesson 23, predicting grams of product produced in a reaction, which is really the same as lesson 22 with an extra step where we predicted moles that a reaction would produce. And if you remember the rules from that, they're on S218. We write the chemical formula out in an equation. We make sure that it's balanced. We then isolate what we're concerned with to get our mole ratio, and we use that mole ratio to do our math. Well, it's the same thing over here with an extra step. In fact, they use the same example in example 1 with our 10 moles of ammonium nitrate, allowing them to decompose into water and nitrogen gas. Instead of asking how many moles, they ask how many grams. So we start out with the same equation. We write out the equation. We balance the equation. We find out that the mole ratio is 1 to 2 and that 10 moles produces 20 moles of the oxygen. And we knew that. So here's our extra step. In chapter 17 or lesson 17, we learned how to convert the moles of a compound into grams by using the atomic mass to find the formula weight. So in an H2O molecule, you break down the the hydrogen and the oxygen. We have 2 moles of hydrogen times the atomic mass equals 2. We have 1 mole of oxygen times the atomic mass, which is 16, which if you recall comes right off the periodic table. We add those together and that gives us the formula weight. We then take the formula weight and we multiply it by the amount of moles we have. So it would be 20 times 18 equals 360 grams, and that gives us the grams of H2O in that one. They have another example on S225 that they did not work out in the book for you, so we can work that out together. It's barium oxide plus carbon dioxide equals barium carbonate. So you write it out in the chemical formula. You make sure it's balanced. You have your barium on one side, you have 1 unit of barium on the other. You look at your oxygen. You have 1 here and 2 here, makes 3. And you have O3 here, which makes 3. You look at your carbon. You have 1 carbon here and 1 carbon here. So this equation is balanced. You can check that off. What they're looking for here is how many grams of barium carbonate. If you start with 5 moles of barium oxide, how many grams of barium carbonate can you produce? So here's your barium oxide, which is 1, to barium carbonate, which is 1. That's why in the last chapter, if you had a single reactant at the end, they would put your 1 here. It's 1 of that, it's 1 of that, it's 1 of that, and so you know you have a 1 to 1 mole ratio. Where's my pen? 1 to 1. So 5 moles of the barium oxide is going to be 5 moles of the barium carbonate. You take those 5 and you look for the formula weight. So again, you break up your barium, your carbon, and your oxygen by how many units you have of each, and you multiply it by your atomic mass. You add that together and you end up with 197 grams. You're almost done. You take the 197 grams and you multiply it by the amount they're looking for. The question said, if you begin with 5 moles of barium oxide, how many grams of the carbonate? It's a 1 to 1 ratio, so 5 times 197 gives you the results. So give that a go. Probably the most complicated part is adding the extra step at the end. If you remember to write the correct balance formula out, then take a look at the annotated answer key that I'm going to send you by email and make sure you're working with the right chemical formula. That will make it easier if you're having a problem with these. Remember, if your product or your reaction is a diatomic gas, like it was in the oxygen, remember those float around and you have to add that 2 subscript. And number 3, if you're having trouble, use the annotated answer sheet to check each problem as you go so you don't get all the way down to the bottom of the problems, and that will help you. Have a great week, and I will see you when I see you.